Hello everyone, welcome to Tech-Lavya. Please like, share and subscribe.
Today we are starting the fifth unit, which is electrical machines, and we are going to discuss three-phase induction motor. Fine. Well, we'll be covering this topic in two lectures, and in today's lecture we'll be discussing the construction of induction motor, the constructional detail, and we'll be discussing the types of induction motor. Okay. Further, now let me tell you that from the name itself it is quite clear that this is three-phase induction motor. Okay, so it works on AC. Fine. So this actually falls under the category of AC motor. Now we have one more category which is DC motor, which we are going to study in a different section. Basically, DC machines are divided into two categories, DC motor and DC generator, and that we will be discussing in a separate section. So today we will be talking about three-phase induction motor, its constructional detail as well as the types of induction motor. Okay. So basically there are many types of motors available. You have DC machines, so DC motor, then you have AC motor, and even in AC motor you have many types. Various kinds of AC motors are available. But if you talk about the popularity, then this three-phase induction motor is one of the most popular motors which are used at various places. Okay, so let me tell you why it is used at many places, or why it finds such extensive applications. Because basically the advantages, induction motors are very simple. They are quite rugged as in they are quite unbreakable. Okay, they are cheap and they have got a good efficiency, and it requires minimum maintenance. Okay, and as far as three-phase induction motor is concerned, it is self-starting. If you talk about single-phase induction motor, it cannot start by itself, but three-phase induction motor can start itself. Okay, you do not require anything external. Fine. But then if there are many advantages, then there has to be few disadvantages as well, right? So even three-phase induction motor is no exception. So the disadvantage is that if you want to change the speed, then efficiency has to be compromised. Okay, and secondly, if load increases, if you increase the load, then the speed would decrease. So that was all about the introduction and few advantages and disadvantages of induction motor. Now let us talk about induction motor. The same thing is written here also. But if you compare induction motor with DC motor, in DC motor what is there is you have North pole and South pole, that is either permanent magnet or electromagnets are used. Remember at the time of AC circuits we discussed, we had a small discussion about how this AC is generated. I told you that in detail we will be covering it, the same topic later. Correct. So we saw how AC is generated. Okay, this is, of course, it was DC generator, but now we are talking about DC motor because the construction is more or less same. In fact, motor and generator can be interchangeably used. Fine. So basically, yes, first thing first. Before going to DC motor or say induction motor, let us first understand what do you mean by motor. So basically motor is a device which converts magnetic energy in electrical energy into mechanical energy. Okay, so motor is a device which converts electrical energy into mechanical energy. Means what? It means that we will be giving the electrical signal as the input and it would give us mechanical energy. Means the motor will rotate. Correct. Actually motor consists of two parts. Okay, so you have the inner thing which is called rotor, that rotates. Fine. So you have AC motor, you have DC motor. So induction motor comes under AC motor. So if you compare this AC motor or induction motor with DC motor, in DC motor, I shall tell you how it looks like. So here you have the magnet, okay? These can be permanent magnet or electromagnets. And then you have conductor, coil, which is called armature. Okay, so this armature is given the supply. Fine. So you can see that if you compare these two conductors, the currents are flowing in opposite direction, right? So what happens is this north pole and south pole, it has magnetic field associated with it. Magnetic lines of forces start from north pole and they go towards south pole, correct? So they have its own magnetic field. Now when this current flows through this armature, it again induces or produces magnetic field, okay? And the magnetic field produced by this current inside the armature interferes with the magnetic field produced by this electromagnet or permanent magnet. So they both interfere with each other and a torque is produced. In this process, this armature starts rotating. Okay, so when armature starts rotating, it means what? We had given electrical signal and armature is starting, to rotate. It means we have converted electrical energy into mechanical energy. So this is how DC motor operates. Now remember, here the electric power was directly given to armature, right? So this is called conduction. This process is called conduction. So DC motor can be called as conduction motor, but in case of induction motor, why this motor is called induction? Because we have studied Faraday's law of electromagnetic induction, correct? And we have seen in transformer also. Okay, now what happens in case of transformer or in case of mutual inductance? We have studied such phenomenon, right? So when the current flows through this coil, flux is produced, correct? Magnetic field is produced. When this magnetic field interacts with this coil, automatically here also magnetic field is produced, right? Correct? So we have here one coil and another coil. These are not connected to each other. They are electrically or physically isolated. But current is flowing in coil 1. Now because of the flux linkage, magnetic field is produced in L2, which is another coil, and this type of magnetic field production is called mutual inductance, right? So this is represented by M. So this phenomenon is, I can say that magnetic field is induced. This process is called induction. And in turn, of course, electrical signal is produced. If this field continuously changes or if the flux changes, then the current also starts flowing because of the induced EMF. Here we get the induced EMF because of changing magnetic field. And due to changing magnetic field, EMF is induced and then the current starts flowing. Fine. So that was Faraday's law of electromagnetic induction. So this was the process of induction. So basically here what happens is the rotor does not receive that electrical power directly. Okay, so it does not receive it by conduction, but there is a process called induction. So what do is we give supply to a device called stator. We will come to that, and the field is induced in the rotor. So that is why the name is given as induction motor. Fine. As it is written that this process is quite similar to magnetic induction in transformer. So how does it look like, or what components are there inside induction motor? So you can see various components of induction motor. Basically, See, it has many small components, but then very important components are stator and a rotor. So stator is a stationary device, as it is quite clear from the name itself. Okay, stator is stationary and rotor is which rotates. So you can see that this is stator, okay, and it has a stand. So this is a stand which provides, we can keep it on some platform. Then it has a frame. Then rotor is there. So this is the rotor, and this rotor goes inside it. Okay, so this is actually placed inside this stator. Fine. And then you have end bell. End bell is just to close it, just like the lid of a container. Fine. Okay. So stator is basically the outer structure. Okay, and it is a hollow structure. It is just like a container in which we keep few things, isn't it? So it is a cylindrical hollow structure, and it is made up of laminated steel. Now, why laminated steel? We have studied in transformer also, so as to reduce the losses. And since it is a three-phase induction motor, three-phase windings are connected inside the stator, and either these three-phase windings can be connected in star or delta. Okay, so there are three-phase windings which are placed inside the stator. Stator basically has stampings. So I'll just draw and I'll tell you. So suppose if this is the frame, okay, so you have such kind of structure. Okay, so these are the stampings. So in between these stampings, three phase, windings are placed. This is a center shaft. Okay, so these are the stampings where, see here coils are placed or windings are placed in between these slots. Okay, fine. So these conductors or windings or coils, whatever you call them, these receive electrical signal. And which type of electrical signal? Which type of electrical signal do they receive? Three-phase signal, because this is a three-phase induction motor. Had it been single-phase induction motor, it would have received single-phase supply. Fine. So basically this was about stator. So stator has slots in between, okay, and we put windings in the in those slots, and then those windings are connected in star or delta, and we give three-phase supply. Fine. So obviously what will happen after this? Come on, what will happen? When the current starts flowing, it produces magnetic field. Okay. And inside this stator, we keep this rotor. Correct? So rotor is mounted on a shaft and its inner cylindrical core. Now this rotor is of two types: squirrel cage rotor and slip ring or face wound rotor. So this is the structure as I was talking about, correct? And this is how it physically looks like. So these are the stands so that it can be kept safely. Okay, and this outer structure is the stator. Okay, and see, these are the windings, and this is the core. And in this place, so here the rotor is kept, okay, in this place. Fine. And this is the top view. Okay, so this is how it looks like from the top view. So you have the rotor slot, you have the stator slot, etc. Fine? Okay. So let us talk about squirrel cage. Yes, it is the same squirrel we see in gardens. Okay. Now why squirrel cage? Because the construction resembles the cage which was used to keep squirrel. Okay. So that just a structure resembles the cage. Okay. Now it consists of a cylindrical laminated core with slots parallel to the shaft axis. See, this is how it looks like. Okay. So basically these are the endpoints. Fine. And you have the bars connected like this. Fine. So this is how it looks like. Okay, so this is a 3D structure. Correct? So it consists of a cylindrical laminated core with slots parallel to the shaft axis. So they are talking about these slots. See, these slots. Okay, these are the parallel bars. Fine. Then slots contain bar conductor. Please remember, we do not have a winding kind of thing. They have a solid bar which are placed in between. These slots contain bar conductor, and at both the ends of the rotor, bar conductors are short circuited by the heavy end rings. So you can very well see that these are the heavy end rings. So they are short circuited. What does that mean? That they are connected together. And now since these are made up of conductors, obviously I would say that those are short circuited. Fine. So end rings and bars conductor form a case similar to squirrel cage, and that is why the name given is squirrel cage rotor. Now these rotor bars are permanently short circuited. Otherwise they cannot, hang in air. So to provide mechanical strength, these end rings are connected at both the ends. Okay, like this. So you cannot, disconnect it whenever you want. They are permanently connected. So now what is the problem? Since they are permanently short circuited, you cannot connect an external resistance. Okay. So if you wish to change the speed, fine. If you wish to change the speed, this is an. It is not possible to connect a series resistor. This is A. Yes. So what happens is, suppose I wish to change the speed. How will I change the speed? By changing the resistance. But even if I connect the resistance, it will not have any effect because all the bars are short circuited. So the problem with squirrel cage motor is that the control of speed is a problem here. Okay, because you cannot modify the circuit. Fine. So this is another you can say view of the squirrel cage motor, and this is the cut section. Okay, the third figure shows the cut section. So basically, and one more thing, yes. So now if you have noticed, these bars are not exactly parallel, right? They are slightly tilted. So these are called skewed. Okay, they are not exactly parallel, slightly they are twisted or tilted. Okay, so this structure is called skewed. So I would say that they are not exactly parallel, but they are slightly skewed. Now why they are skewed? Because this skewing helps to reduce the locking tendency of the rotor. Now what do you mean by locking tendency? Now imagine that you have a stator and in between you have a rotor. Correct. So obviously magnetic field is produced and current is flowing. So this rotor and stator teeth will try to attract each other. So one point will come when they will attract each other and they will get locked up. So once they lock up, then the motor will not rotate, or rather I should say the rotor will not rotate. So this is called locking condition. Fine. So if you wish to protect your motor from that locking condition, this skewing is used, and magnetic humming is also reduced. Now we come to slip ring or face wound rotor. So how does it look like? It looks like this. Fine. So in this type of rotor, three-phase winding having the same number of poles as the stator is placed in the rotor slot. Now suppose stator has 6 poles, then even rotor will have same number of slots. Okay, if it has 3 poles, then the rotor will also have 3 slots. Fine. Generally rotor winding is connected in star. So here in the second diagram it is shown. So this rotor winding is connected in star. And you can see why this is called slip ring. Why this is called slip ring? Because see, and ultimately I shall use this another color pen. Yes. So see, they are brought together and they are connected to this slip rings. Okay. So they are connected in star fashion. Okay, so one ends are connected together and another ends are connected to slip rings. See, one end, these ends are connected together and another end goes to the slip ring. Okay, so see, these are connected to slip ring, and ultimately slip rings are connected to rheostats. What is rheostat? Variable resistor, right? You must have used it in class 11th or 12th. Okay, so very well you can see that here rheostat comes into the picture. It means that ends are not short circuited here. For that purpose, I mean, because of that only I could connect external rheostat. Now what is the advantage of connecting rheostat in the circuit? So that I am now able to change the resistance. Now what do I achieve by changing the resistance? I can change the torque or I can change the speed. So what is the advantage of slip ring induction motor? The advantage is the two ends are not short circuited and the second ends are brought out and connected to slip rings which are connected to external rheostat, and by changing these resistances with the help of rheostat we can change the speed. But for several advantages, squirrel cage induction motor is preferred. See, you can see here that speed can be changed if you use slip ring rotor, right? But in squirrel cage motor or rotor, actually the motor which uses squirrel cage rotor is called squirrel cage motor. Okay, so for several reasons squirrel cage induction motor is preferred. Okay, we shall be talking about the working in the next class. In this class we are discussing about the construction part and we are comparing various types of induction motor. Okay, so this is the comparison. This is very important. Fine. So these are the or you can say that these are the advantage of squirrel cage rotor over slip ring motor. Okay, so the construction of squirrel cage is simple if you compare it with slip ring. Secondly, squirrel cage rotor consists of bars which are shorted at the ends, but in slip ring rotor it has three-phase windings which are exactly similar to the stator windings. Then the problem of squirrel cage rotor is you cannot connect external resistance, whereas in slip ring rotor you can connect external resistance. Now this is the advantage of slip ring rotor. Now if we talk about cost, squirrel cage rotor is cheap and slip rings are costly. Secondly, in squirrel cage rotor you do not have slip rings or brushes, whereas in slip rings you have slip rings and brushes. Now the biggest advantage is in squirrel cage rotor copper losses are less, so you have higher efficiency, which is a problem with slip ring rotor. You have higher losses and hence the efficiency is less. Now if we talk about applications, then squirrel cage rotors are used in fans, blowers and water pumps, whereas slip ring rotors, they find applications where there are big machines like lifts, cranes or compressor. Okay, so this was all about today we discussed everything about the construction and types of motors, and we also compared both types of motor. Now in the next lecture we shall be talking about the working of induction motor. Okay, see you till then. Bye.